It is a fact that can seem almost impossible to believe. Mount Everest, that colossal peak, rock ice is not static. It is not a finished monument. It is, in fact, still growing. Each year it pushes itself a little higher towards the heavens. The growth is minuscule, almost imperceptible to us. About 4 millimeters every single year. 2 small coins stacked, roughly the same. A tiny measurement, yet it speaks to the planet's ceaseless power. It is a secret movement, a silent ascent, happening on a scale far beyond our own human lifetime. We think of mountains as symbols of permanence. They are the epitome of stillness and ancient, unchanging strength. For millennia, they have stood as silent witnesses to the comings and goings of civilizations. So, the idea that the very tallest of them all is actively getting taller is quite a surprise. It challenges our perception of the world as a fixed and solid place. It reveals that the ground beneath our feet is alive with motion. The forces that shaped our world millions of years ago have not ceased their work. They continue, day by day, to build and reshape the very landscape we inhabit, 1 millimeter at a time. This constant, subtle growth is a profound reminder of geological time. Our lives are fleeting moments in the great, slow story of the Earth. What appears to us as an immovable, eternal feature is, to the planet itself, a work in progress. The great Himalayan range, with Everest as its crown jewel, is one of the youngest mountain ranges on Earth. It is still in its dynamic youth, full of the energy that comes from the collision of continents. This upward thrust is a testament to the planet's relentless dynamism. The secret to Everest's growth lies deep within the Earth. It is a story of continents in motion. Our planet's surface is not a single solid shell. It is broken into enormous sections, like a giant cracked eggshell. These are known as tectonic plates. They float upon a sea of molten rock, moving with incredible slowness, but also with unstoppable force. The journey of one of these plates is what gave birth to the Himalayas. The vast landmass we now call India was once an island, drifting northwards across an ancient ocean, centimeter by centimeter, over millions of years. About 50 million years ago, this journey reached its dramatic climax. The Indian plate collided with the immense Eurasian plate. It was not a sudden crash, but a slow, grinding convergence that continues to this day. Because both plates are continental crust, one could not easily slide beneath the other. Instead, the incredible pressure caused the land to buckle and fold. The edges of the two colossal plates crumpled, like the hood of a car in a slow-motion collision. This immense crumpling forced the rock upwards, lifting it higher and higher into the sky, creating the magnificent Himalayan range. This process of uplift did not end when the mountains were formed. The Indian plate continues its relentless push northwards, burrowing beneath the Eurasian plate at a rate of about 5 centimeters per year. This constant pressure acts like a powerful jack, continually forcing the mountains upwards. While erosion from wind-snow ice works to wear the mountains down, the tectonic uplift is currently winning the battle. This geological struggle is what accounts for Everest's annual growth. It is the living echo of that continental collision, a process that is still actively shaping the roof of the world. This constant movement also makes the region one of the most seismically active in the world. The immense strain that builds up between the plates is often released in the form of earthquakes. These tremors can cause sudden dramatic shifts in the landscape. A major earthquake can sometimes cause Everest's height to drop in an instant, as the rock settles. However, over the long arc of geological time, the steady upward push of the tectonic plates is the dominant force. The mountain rises, falls back a little, and then rises again, continuing its slow, inexorable climb into the stratosphere. How do we know with such certainty that a mountain is growing by just a few millimeters a year? The answer lies in remarkable technology and painstaking human effort. Scientists cannot simply use a tape measure. They rely on incredibly precise methods that detect the tiniest shifts on Earth's surface. One of the most important tools is the Global Positioning System, GPS. This is not the same as the GPS in your car or phone. These are scientific-grade GPS receivers placed permanently on the mountain, bolted directly into the bedrock. The stations stay in constant communication with satellites. By receiving signals from multiple satellites, the receivers calculate their exact position on the globe with astonishing accuracy, down to the millimeter. Scientists leave these instruments for long periods, then compare position data year after year. A consistent upward trend in the data shows the mountain is getting taller. It is a slow, patient science, mirroring the process it measures. Another vital method uses modern trigonometry and surveying, leveling. Teams place a theodolite at known points and measure the angle to the summit. They combine angle measurements with precise distance calculations, often using lasers to calculate the mountain's height. To confirm growth, teams return to the same observation points years later and repeat the measurements. If the calculated height is greater, it corroborates the GPS data. Everest's final height is a matter of international agreement and debate. The 2015 Nepal earthquake sparked questions about height changes. A joint Nepal-China mission was launched to remeasure the peak. Their combined efforts, using GPS and ground-based surveys, led to a new official height declared in 2020, 8,848.86 meters. This figure, which includes the snowpack, confirmed ongoing growth and gave the most accurate snapshot of this ever-changing giant. This tiny annual growth matters for more than just a line in a record book. For scientists, it is a vital sign of the Earth's health and activity. By studying the rate of Everest's uplift, geologists can better understand the immense forces at play between tectonic plates. This knowledge helps them model how mountains are built and how continents evolve. It also provides crucial data for assessing earthquake risks in this densely populated region of the world. Each millimeter of growth is a clue, helping to piece together the grand puzzle of our planet's inner workings and predict its future movements. For the climbers who are drawn to its slopes, the changing height adds a unique dimension to their quest. The summit is not a fixed goal, but a moving target. Every expedition that reaches the top stands on a slightly different mountain than the one that came before. It deepens the connection between the person and the peak, a shared moment on a journey that belongs not just to the climber, but to the planet itself. The maps may need slight updates, and the official records may change, but the spirit of the challenge, to reach the highest point on Earth at that specific moment, remains eternal. The slow rise of Everest also has profound implications for the local environment and the communities that depend on it. The same tectonic forces that push the mountain up also shape the valleys, divert the rivers, and influence the flow of glaciers. Understanding this movement is crucial for managing water resources and preparing for geological hazards like landslides. For the Sherpa people, who hold the mountain, known as Chomolungma, as a sacred mother goddess, its living, growing nature is a deeply ingrained part of their worldview. It is not an inanimate object to be conquered, but a dynamic presence to be respected. And so, Mount Everest stands not as a relic of the past, but as a vibrant participant in the present. Its continued ascent is a quiet, powerful declaration that our world is not finished. It is being forged and reforged in a process so slow we can barely perceive it, yet so powerful it can lift rock to the edge of space. The next time you see a picture of that iconic peak, remember that it is not entirely as it appears. You are looking at a mountain in motion, a giant on a slow and steady journey upwards. And one cannot help but wonder, how much taller will it be in 1,000 years or 1,000,000? It is a story written not in words, but in the slow, powerful language of rock pressure time. And it is a story that is still being written, year after year. The mountain is not just a destination. It is a living entity. It breathes in a way with the slow pulse of the Earth's core. Please like and subscribe for future videos.